All right, calculus, here we are. We got to skip the sponsors for today. Um, received that notice for an e-learning day a little late and didn't have anything prepped, as I felt pretty confident we would have school, like my girls have school today. So here it is, folks. Here it is. So we are going to have a little bit of notes, and then we're going to have a little assignments at the end, okay? So we can progress through notes. Those videos can be helpful too, because you can pause things and come back. So we maybe started this one the other day and didn't finish it. If not, this is still a great one here. So find where f of x, which is increasing and decreasing, and state any min or max values. Now that is the first derivative, kind of the first derivative test here. All right, so what do you got to do? When in doubt, this part of the chapter, take the derivative, set it equal to 0. So find the derivative of this. It's pretty easy, set it equal to 0. All right, so I can factor out a 12x from all three terms. I'm left with 12x on the outside, x squared minus x minus 2. All right, then what multiplies 2 differs by 1. It's a negative 2 plus 1. Look at that. Factors really nicely. I almost forgot about that critical number there, but 12x equals 0, so x is 0, x is a negative 1, and x is 2. So I need to go in order here. I'm going to make my table. All right, the curve is doing something. Now, this is a hypothetical situation, so let's not worry about that right now. But my curve is gonna do something from negative infinity to negative 1. That's my first critical number. Then from negative 1 to 0, my second critical number. Then from 0 to 2, my third critical number. And then lastly from 2 towards infinity. All right, so in this interval, I need a nice test number that fits within, like negative 2. It'd be great if I can use 0. I can't, since it is a critical number. So what's in between negative 1 and 0? How about negative 1/2? What's in between? You can see that I left out 0 initially. Then I started to plug it in. I was like, wait, that's a problem. Then I have 0 to 2, the interval, and a good number to use is 1. And then 2 to infinity, a good number to use is 3. So I need to figure out what the derivative is doing. We noticed what that means the other day using Desmos. So if I plug negative 2, now you should always plug it into like the best factored form of the derivative. If I plug negative 2 and I get a negative times a negative times a negative, which is a negative. That means f of x. If the derivative is negative, that means f of x is decreasing, okay? If I plug in negative 1/2 back into my very factor derivative, I get a negative times a negative times a positive, which is a positive, and the derivative is positive, so the function's increasing. Then lastly, or not lastly, if I plug in 1, I get a positive times a negative times a positive, which means the derivative is negative. That means f of x is decreasing. And if I plug 3 in, positive, 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 that means the derivative is positive. So f of x is increasing. So it's increasing on negative 1 to 0, union 2 to infinity, and it's decreasing on negative infinity, negative 1, union 0 to 2. Now, let's talk about the min and max values. So here's what's good. This is a different curve because this is a cubic, and you have one that's to the 4th here. One that's to the 4th, they kind of make like a W shape if it's positive. Anyway, let's just take a look at this hypothetical cubic here. Maybe I've cut off other, part of it, but this graph is clearly increasing. And then right here, it starts to decrease. So this is a local max. When my curve goes from increasing to decreasing, I have a local max, Okay, I say local because this graph goes up forever and it goes down forever. So there's no absolute min or max here. We say absolute min or max when we have a defined interval, like what we first learned in 4.1. Okay, then when the curve goes from decreasing to increasing, I have a local min. So from increasing to decreasing, local max, decreasing to increasing, local min. And the reason we need that is we're not going to graph any of these, okay? So if I see that f of x is going from decreasing to increasing, then that means at this transition point, I have a local min. And what's the transition point? It's the number I see twice. It's negative 1. When I go from increasing to decreasing, that means I have a local max. All right, and that's at 0. And then I have another. So I got a potential, like there's 2 points that could be local mins, but one of them might win out because it's the smallest. Increasing and decreasing, that's another potential for a local min at 2, at transition points. All right, so we're going to have a lot of practice with that. Anyway, how do I figure those out? So again, possible mins. Possible mins at, first one, at -1. So I take -1 and I plug it back in to the original. I plug -1 in back into the original. It's what f of x is doing. So when I plug -1 back in, I believe I get 0. Again, that's a possible because I had 2 possible mins. So my other min is going to be at 2. I plug 2 back into the original. I got -27. Well, -27 is a lot lower than 0. So this is the local min. There's one of them. I just had to investigate because there is 2 possibilities, but one out there. And then when I go from increasing to decreasing, and that transition point is 0, that's where my local max is. If I plug 0 back in the original, f of x, I get 5. And that looks good because 5 is definitely bigger than -27. Some students make errors. They get an opposite, right? They have the right critical numbers, but then they'll tell me like local min at, 2.5 or something like that, or 27. And they'll say local max at 0, -27 or something like that. Especially if you get like decrease and increase and you have that flipped, then that should like just look here. I have a min at -27 and a max at 5. That does not sound incorrect. All right, that was example 1. So where are we going next? Yes, so where we are headed next is the following. So I need you to write this down. Just this definition here. It's called the concavity test. If f double prime is greater than 0 for all x in some interval I, then the graph of f is concave up on I. We'll talk about concavity. Give you a graph when I see again in class. You can kind of see what that means. If f double prime of x is less than 0 for all x in I, then the graph of x is concave down. All right, on I. And then, so concave up, we're going to say CU. Concave down, we're going to say CD. So if you go from concave up to concave down, or concave down to concave up, you've changed concavity. That's called an inflection point. Those are pretty interesting. All right, so maybe you want to pause this right now where you can see it and read everything and write that down, because in 10 seconds on my time here, I am going to... I'm going to explain what concavity means. Again, it's going to make more sense when we see it on a graph in class. All right, so concave up means the tangent line is below the curve. So that curve is above or up from the tangent line. That means the curve is above the tangent line. Concave up means if I draw a tangent line to the curve would be above it, up. Concave down means the tangent line is going to be above the curve. So curve is down. It's below the tangent line. So I draw a tangent line and the curve is below it or down. Concave down. Inflection points are pretty interesting and important. We'll talk about their applications when I see you again in class. All right. So these are the big ones. These are the following are the big ones. So as you can see, that was all about... It was all about the second derivative. I'm sorry, it was all about the second derivative. Okay, so here it is. I'm going to try to make this, look at that. Discuss the curve y equals x to the 4th minus 4x to the 3rd with respect to, which is WRT. If you're in a math class in college and the professor writes WRT, that means with respect to. If and only if is another thing they'll write, and they'll write IFF. That stands for if and only if. With respect to concavity, points of inflection, and local min or max values. So I take the derivative, 4x to the 3rd minus 12x squared, and I set it equal to 0. I can get a lot of info for my first derivative. All right, so I take the derivative, set equal to 0, and I factor out the 4x squared, leaving me with x minus 3. So cover-up method says 4x squared equals 0, so x is 0. And then x minus 3 is 0, so x is 3. I have 2. So it's pretty interesting. I could have had 3 solutions there, but I only have 2 critical numbers. So I have 0 and 3. So negative infinity to 0, 0 to 3, 3 to infinity. Those are my 3 different intervals. So Again, this is the way to do it. There's ways, but like this is the best way to organize. It's always going to lead to a nice organized answer. That's what we should do in higher level math. We should take routes that lead to nice organized answers. So you got test number of -1 here, 1 and 4. So what's the derivative doing? If I plug -1 here, so this is always going to be positive. So a positive times a negative is a negative. F of x is decreasing. If I plug a positive 1 in there, it's going to be positive times a negative, which is another negative. So it continues to decrease. It kind of like hits that point and then continues to go back down. Interesting. So it's not always, does it alternate? And then 4. Plug 4 and I get a positive times positive. So it's positive, it's increasing. All right, so I only have a min here. I have no local max. I only have a min. So first off, I'm going to say it's increasing on 3 to infinity. It's clear to see. And then it's decreasing on negative infinity to 3. Like I don't have to put negative infinity union 0 or to 0 union 0 to 3. I don't have to do that. I can just say it's decreasing on negative infinity to 3 because there's nothing at 0. There's no asymptote there where it's not allowed. Okay, so it has no local max. It has a local min at the transition point is 3. If I plug 3 in there, I think I get 81 minus 108, which looks very much like a min. All right, so that's everything I can get from the first derivative. I can get intervals of increase, decrease, and local min max. Now, second graph gives you concavity. There's a lot of things you can learn in this class and other classes about the second derivative that we'll talk about in class. All right. First derivative gets a lot of love because it's, rate of change, and that's very important. All right, so the first derivative was 4x to the third minus 12x squared. The second derivative is 12x squared minus 24x. I'm going to factor out the 12x we have in common, leaving me with x minus 2. Cover-up method gives me 2 critical numbers. They're still critical numbers of 0 and 2. So I make the same intervals. I make the same table. I have a first interval of negative infinity to 0, 0 to 2, 2 to infinity. I get the same test numbers that work. So if I plug my test number of -1 in here, I get a negative times a negative, which is positive. If I plug 1 in, I get a positive times a negative, which is a negative. And if I plug 3 in, I get a positive times a positive, which is positive. I accidentally started writing increasing, decreasing, increasing, but no. So a positive means it's concave up. A negative means it's concave down. A positive means it's concave up. All right. What does that mean? So it's concave up on negative infinity to 0, union 2 to infinity. It's concave down on 0 to 2. We're doing a lot more with the derivative, but that derivative is pretty easy. Okay, now we're just, doing some algebra. And I have inflection points again when I change concavity CU to CD, and that was at 0. Inflection points at 0, 0. Again, I go back to the original. Y equals x to the fourth minus 4x third. I plug 0 and 2 in there, and I have inflection point at 2, -16. 2, -16, where I change concavities. Concavity, and that was at 0 transition point, and that was at transition point at 2, 0, 0, 2, -16. Go back to that original. All right, folks, this is the same as number 2. And we'll just continue with this. We want to spend some time on this. This question is great because it answers the previous questions that we had with the first derivative test. We got to do everything here. All right, so you have 2x to the third plus 3x squared minus 36x. So 0 is equal to 6x squared plus 6x minus 36. Factor out the 6. Just leave it on the outside. Don't divide everything. Just factor out, especially if it's a negative. And then I can factor that easily to be x plus 3, x minus 2. Cover-up method gives me 2 critical numbers this time of -3 and 2. Again, this is the first derivative. That's what that says to the left. Negative infinity, -3, -3 to 2, 2 to infinity. I got test numbers of -4, 0, and 3. Again, I'm plugging my test numbers in here. If I plug -4 in here, I get a negative times a negative, which is a positive, increasing. If I plug in 0, I get -36. Like, it's clearly there. But also positive times a negative is a negative because -36 is negative. If I plug in 3 here, I get a positive times positive, which is a positive. All right. So if I go from increasing to decreasing, That's a max. So I'm going to have a max at -3 something. And then I go from decreasing to increase. I'm going to have a min. I'm going to have a min at 2 something. And I need you to fill that in. All right. So first off, I said we are increasing on negative infinity, -3, union to infinity. And we're decreasing on -3 to 2. Now the local max is at -3 something. Plug -3 back into the original. I trust you got 108. You got 27 and 135, and then it looks like -54. So I'm gonna say like maybe 81, and a local min at 2 something. All right, so let's try this. 16 plus 12, so 28. 28 minus 72 is that -44. All right, you guys can try. Anyway, take the second derivative. So the first derivative was 6x squared plus 6x minus 36. What's the second derivative? That's 12x plus 6. You set that equal to 0. You get 1 critical number here for the second derivative test. That's going to happen more often for us. They typically give you cubics to start with. All right, so -1/2. -1/2, that's all right. -1/2 is a critical number. So negative infinity, -1/2. -1/2 to infinity, a test number of -1. We can find that. We can use 0 here. All right, so I'm going to plug -1 in here, and that's going to give me negative. I'm going to plug 0 in here. That's going to give me positive. I go from concave down to concave up. Concave up on -1/2 to infinity. Concave down to negative infinity, -1/2. And I have inflection point at -1/2. And I didn't plug it in. Plug -1/2 into 2x to the third plus 3x squared minus 36x. I know it ends with a plus 18, but other than that, I need you guys to finish that one. All right, so those are some good notes. We're going to continue with those tomorrow, whether in person or e-learning. I'm going to assume. If today was e-learning, I'm going to go out. Now, don't say Mr. Ruck said we're going to have e-learning tomorrow, but I'm going to get these videos out and start on ones for tomorrow, just in case. E-learning assignment. All right, so here is on a separate sheet of paper. So that does not mean you will lose a point if this is on your notes. You understand? Like, you will lose a point for turning something in not looking very professional on a separate sheet of paper or papers. This is your e-learning assignment. It could be 5 points. It could be 6 points. It could be 10 points. It's going to be some points, though, for 218. All right, calculus. For numbers 1 and 2, you're going to state the intervals of increase and decrease in any local min or max values. This is all just the first derivative test, okay? So you have f of x is 1 plus 3x squared minus 2x to the third. See if you can take the derivative of that and set it equal to 0 and solve that. See if you can do that. Or you can, wait a few seconds and see. That's the derivative. Factor out the 6x you got in common, leaving you with 1 minus x. 1 minus x. You have two critical numbers of 0 and 1. 0 and 1. So my intervals, negative infinity 0, 0 to 1, 1 to 2. All right. I'm using... I don't know why I use -1/2. You don't need to use -1/2. You can use like -1. I think you should use -1 instead. That's silly. We're going to use -1. All right, 1/2 definitely, and then 2. All right, so if I plug -1 in here, I get a negative times a positive, which is a negative, so I'm decreasing. If I plug in 1/2, I get a positive times a positive, which is increasing, which is positive, so it's increasing. And then if I plug in 2, I get a positive times a negative, which is decreasing. If I go from decreasing to increasing, I have a min. I go from increasing to decreasing, I have a max. So it is increasing on 0 to 1, as it clearly says. It's decreasing on negative infinity 0, union 1 to infinity. Okay? Just from this. That's why we set up the table, because then we have the answers. We can see where a min and a max are. It's really nice. So I have a local min at 0. That's that transition point there. That's pretty easy. Plug 0 into your original and you get 1. Then I have a local max at increasing and decreasing, so it's 1. I have a local max at 1, 2. 1, 2. Pretty nice answer there. All right, again, pause this, get these down. I want to see all of the work. And folks, same question for same sort of deal for number 2. Here we are, folks. Trig time. All right, so this is f of x. This is f of x. And because, as you know, trig functions are periodic there, we got to just look at stuff on the unit circle. 0 to pi or 2 pi, or else this would continue forever. All right, what's the derivative of cosine x all of it squared? 2 cosine times the derivative of cosine minus 2. What's the derivative of sine? It's cosine. Okay, so there we go. Factor out the negative 2x you have in common, leaving you with sine x plus 1. Cover-up method. Set that equal to 0. Cover-up method. Set that equal to 0. Should get some pretty nice answers. So I get cosine equals 0. Where on the unit circle is cosine is 0? Almost made a boo-boo. Cosine is 0 here and here. That's pi over 2 and 3 pi over 2. Sine x plus 1 is equal to 0. Sine x is a negative 1. Where in the unit circle is sine, which is y negative 1. 3 pi over 2. So I see the same critical number twice. Just need to use it once. So it's really these two. So 0 to 2 pi, my stipulation. So my intervals are going to be 0 to pi over 2, pi over 2 to 3 pi over 2, 3 pi over 2 to 2 pi. So infinity and negative infinity not being used here. All right, so you guys got calculators, you know, mode, radian mode if you got to. We'll talk about what we know here, but I'd use the test number of, you can use whatever you want, but I'm going to say pi over 4, okay? So here's my derivative. If I plug pi over 4 in here, so first off, cosine pi over 4 is positive. So you have a positive times a negative, and it is negative root 2. And then sine of pi over 4 is positive. So then add 1 because it's root 2 over 2. If you add 1 to it, it's more positive. So negative times a positive is a negative. So f of x is decreasing on that interval. All right, so pi. All right, cosine of pi is a negative 1. A negative 1 times negative 2 is a positive 2. Sine of pi is 0. 0 plus 1 is 1, so you have a positive times a positive, which means f prime of x is positive, so it's increasing. And then 7 pi over 4. Negative 2 times cosine, 7 pi over 4, that's root 2 over 2, it's positive. So negative times a positive makes it a negative, and it is in fact negative 2 times cosine of 7 pi over 4 is that. Sine of 7 pi fourths is a negative root 2 over 2. There's like a negative 0.707, so if you add 1 to it, it would actually become positive. A negative times positive is a negative, and that's decreasing. Yes, there are colleges that are going to expect you to know all that without the use of calculator, because that is what you did in pre-calculus. All right, so we can get this down. You guys can use calculators, but that's what's going on. We're going from decreasing, increasing, and decreasing. All right, so I got a local min at pi over 2, and I have a local max at 3 pi over 2. So it's increasing only on that middle interval, and it's decreasing on 0 to pi over 2, union 3 pi over 2 to 2 pi. So you have a local min at pi over 2. Again, you go back to the original, cosine squared x minus 2 sine x, and I did it over here. Cosine pi over 2 is 0, sine pi over 2 is 1, negative 2 times 1 is a negative 2. Has a local max at 3 pi over 2, comma, cosine 3 pi over 2 is 0. If you square 0, so you get 0. Sine of 3 pi over 2 is a negative 1. Negative 2 times negative 1 is positive 2. All right, trig time. And lastly, yes, this is a relatively long video, but you know, it is technical school day. You guys can do it, all right? And it's in calculus. All right, this is from SLU Final. This is number 3. This is from SLU Final. Find the global extrema. That's just, especially if it's on an interval, they're just, what's the absolute minimax? That's what it means. Global extrema, what's the absolute minimax? So it's not asking for increasing, decreasing. All right. So I take the derivative of this and set it equal to 0. 3x squared minus 27, factored out the 3. I could divide it away, that's fine. I get 2 answers of negative 3 and positive 3. Now I need to be on the interval 2 to 8. So those are my 2 critical numbers, but 3 is the one in the interval. All right, so off to the side I do f of 2. So one of the first things we did, f of 2, f of 3, my critical number, and f of 8. Because f of 3 is a critical number, it's gonna have to be either on this interval, absolute max or absolute min. We'll see. F of 2, I believe, is negative 41. F of 3 is, I believe, negative 49. And f of 8 is huge. So you can say absolute, or you can just say min. You know, you have a min at 3, negative 49. I just need to see that you write min. And you have a max at 8, 301. All right, that's what we're going to turn in, whether it's I see you on Wednesday or on Thursday. You're going to turn that in, and it's going to be for points. This is Yak Math Videos, signing out.